Hello everyone, welcome back. Today we're tackling a Leetcode problem called binary prefix divisible by 5. This is one of those problems that sounds a bit complicated when you first read it, especially if you aren't dealing with binary numbers every day, but once we break down the mechanics it actually reveals a really elegant solution. We'll start by making sure we understand exactly what the question is asking, then we'll walk through the logic, and finally write the code. Okay, so here's the setup. We are given a list called nums which contains only zeros and ones. This list basically represents a really long stream of binary bits. Our job is to walk through this list, and at each step, imagine the bits we've seen so far form a binary number. For every single step, we need to check if that binary number is divisible by 5. If it is, we say true, and if it's not, we say false. We return a list of these true and false values. Before we jump into an example, let's clarify what they mean by prefix. Imagine we have the list 0, 1, 1. When we are at the first index, the prefix is just 0. In binary, that's 0. When we move to the next index, the prefix becomes 0, 1. In binary, 0, 1 is just the number 1. Then at the third index, the prefix is 0, 1, 1. In binary, that represents the decimal number 3. So at each step, we are appending a new bit to the end of our binary number. Let's run through that same example to see what the output should be. First, we see a 0. The value is 0. 0 divided by 5 has a remainder of 0, so it is divisible. That gives us a true. Next, we add a 1. The binary string is now 0, 1, which is the number 1. 1 is not divisible by 5, so that's a false. Finally, we add another 1. The string is 0, 1, 1, which is 3. 3 is not divisible by 5 either, so that's another false. So our result list is true, false, false. Just a quick heads up, we'll be walking through the solution logic using Python, but the concepts apply universally. If you're looking for the full solution code in Java, C++, or JavaScript, I've included those at the very end of the video, so you can skip ahead if you need them. Now you might be tempted to just convert these binary substrings into integers and check if they are divisible by 5, but there's a catch. The problem says the list can be up to 100,000 items long. A binary number with 100,000 bits is absolutely massive. It's way larger than what a standard 64-bit integer can hold. If we try to store the actual value, our program will crash or slow down to a crawl. We need a way to check for divisibility without storing that giant number. This leads us to our approach, which the editorial calls Traversal. The core idea is modular arithmetic. We don't actually need the full number. We only need to know its remainder when divided by 5. Here is the cool part. When we append a new bit to a binary number, it's mathematically the same as multiplying the old number by 2 and adding the new bit. For example, to go from binary 1 to binary 3, which is 1, 1, we take 1, multiply by 2 to get 2, and add 1. Since we only care about divisibility by 5, we can just keep tracking the remainder. At each step we take our current remainder, multiply it by 2, add the new bit, and then immediately take the modulo 5 again. This keeps our numbers tiny, always between 0 and 4. Okay, we've talked about the big picture and the modulo trick. Now let's see what this looks like as actual code. I'll put the full solution up on the screen first. And don't worry, after that, we'll walk through the most important sections together. Here is the complete Python solution. It's surprisingly short, right? We define our class and function, initialize a list for our answers, and a variable to track our running prefix remainder. Then we just loop through the input numbers. Let's break down exactly what's happening inside that loop. First, we set up our variables. We have a list called answer which will hold our Boolean results. Then we have a variable called prefix. Even though it's named prefix, it's important to remember that this variable isn't storing the huge binary number. It is only storing the current remainder. We started at 0. Now we enter the loop. For every bit which we call num, in our list we update the prefix. The code says prefix left-shift1 plus num. Shifting left by 1 is the computer science way of multiplying by 2, so we are doubling our previous remainder and adding the current bit. Then, and this is crucial, we immediately apply the modulo operator with 5. This discards the large part of the number and keeps only the remainder, ensuring we never overflow. Finally, after updating our remainder, we check it. If the prefix variable is 0, that means the entire binary number up to this point is perfectly divisible by 5. So we append true to our answer list. If it's anything else, we append false. Once we finish the loop, we return the answer list. So how fast is this solution? Well, let n be the number of elements in our input list. Since we just loop through the list exactly once, performing constant time math operations at each step, our time complexity is big O of n. As for space complexity, we only use a few variables to store the remainder and the current bit. We don't use any extra data structures that grow with the input size, so our extra space complexity is big O of 1, or constant space. It's extremely efficient. Right, that covers the main solution in Python. As promised, for those of you who code in other languages, I'm about to show the full solutions for Java, C++, and JavaScript. I won't be breaking these down in detail since the logic is identical, but just pause the video on your language of choice to check it out. Alright, as promised, here is the full solution in Java. It uses an array list for the result and follows the exact same logic. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version of the solution. We use a vector of booleans here. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript. It looks very similar to the Python version. Hopefully seeing it in a few different languages helps solidify the concepts. So let's wrap it up. The key takeaway here is how to handle potentially massive numbers. Instead of computing the full value, which would be impossible, we used the properties of modular arithmetic to keep our state small. We realized that appending a bit is just multiplying by 2 and adding, and we applied the modulo at every single step. This turned a hard problem into a very simple linear scan. Alright, before we go, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To-Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily Leetcode problem. You know the drill. So I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with the little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now, while it's all free, are yours to keep and use forever. So it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Also, if you're looking for even more Leetcode problems beyond the daily challenge, I've started a second channel called Leetcode Unlocked. It's where I'll be posting solutions to a ton of other problems. So if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. If you want to support the channel, a few people have asked how I plan my solutions. I'm a big fan of sketching out the logic and data structures on a tablet before I code. It really helps. I've put affiliate links in the description to the tablet I use and a few other good options. Using those links doesn't cost you anything extra but really helps me out. Or, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.